Okay, so here is our lesson 15.1. All of our last lessons here in Algebra 2 are all going to be dealing with something called logarithmic functions. So today we're just going to be talking about what a logarithmic function even is. And for a second, we're going to talk about inverse operations or inverse functions. Remember, inverse functions in general are when we switch the x and the y. And we kind of talked about that. So I just want to remind you, so the inverse of something squared, how to undo that is to take the square root. So the inverse is square root of x. Remember that we write inverse with a little -1. The inverse then of x to the third is the cube root of x, right? That's how do you undo something to the third power. To undo subtraction, we add. So the inverse of x minus 2 is x plus 2. The inverse of being multiplied, so this is times 3, the inverse of that is to divide by 3, so that's x divided by 3. All right, those are all inverses that you know. So two that we don't know are when we have exponents as the variable. So if we have something like 10 to the x power, the inverse of that is to take the log of x. Also, if we have e to the x power, remember we learned what e was, the inverse of that is called natural log, and it looks like ln of x. So just recognize all you really need to know, or the most important thing you need to know rather, is that exponents and logs are inverses, and that 10 is the base for log, and e goes with natural log. So make sure you understand both of those. Those inverses happen again when x is the exponent. Notice that the that the variable is the exponent here. It's not anywhere else in the equation. So this is how we convert. This is super important. We've been looking at equations that look like this. They're in exponential form, where we have something to some power equals something else. For the most part, we've been using our calculator, the table function on our calculator to solve these, but now we're going to look at something a little bit different. So pay attention. They actually use kind of some good numbers. So b is the base, x is your exponent, and a, we'll call that the answer. All right, so when we write this in log form, and logarithmic form is going to help us to solve, and you'll see that maybe not today, it may even be next week when we use it to solve. So logarithmic form says that the log with base b, so that's a little b, of the answer equals x. So notice this is how you get x by itself, is by taking the log, because there's no other way to solve for x other than to take a log to get x by itself. So what you want to notice, I kind of think of it like a circle. If it's written in log form, you say b to the x power equals a. So follow that again. B to the x power equals a. Now these other qualifications down here, b has to be positive, b cannot equal 1. I wouldn't even really stress about that. You just need to know these two things that we've put in boxes in red and blue. Okay, so we're going to practice converting between the two, and I actually think it's generally easier to go from log the other direction. So I'm going to start with these two. Remember, it was b to the x power equals a. So on this one, if we rewrite that, that's the same as saying 4 to the negative third power equals 1 over 64. All right, same thing here. b to the x power equals a. So 1/5, that's my b, to the w power equals v. You're not solving anything, you're literally just writing in between the two forms. When we go the other direction, remember we want to have log of the base. So my base here is 3/4, because that's what's being raised. So log of the 3/4 to the power. So that means equals r of s. All right, so remember, that was base, answer, power. So 3/4, the answer is s, the power is r, or the exponent is r. All right, same kind of pattern applying to this very first one. It's going to be log base 3 is 243, and that's when you raise it to the 5th power. If you're confused about that, you just need to go back and look at the rule. That's literally all this is memorizing a rule and putting things where they belong. So make sure you know the two rules, the two patterns for exponential and logarithmic. Okay, so in this example, we're going to use exponents to evaluate each, and they are telling me that this is the formula I'm starting with. And I've actually made this easier for us. We have f of x equals log base 2x. So they want us to figure out what is the value when we plug in 4. Okay, so I'm going to say f of 4. If we plug that in, we're going to have log base 2 of 4. That means, and I want to know, like, what value is that? So remember, we're going to kind of translate that. That means 2 to some power, we can call it the y power, equals 4. Right? 2 to some, because see, I don't know what's out here, so I'm going to call this y. 2 to the y power equals 4. Well, if I make those the same base, that's like 2 to the y power 4 is 2 squared. All right, so if you look at that, now that they have the same base, that would mean that y equals 2. So this would be f of 4 equals 2. All right, if we look at another one, let's say we have 1 over 32 now. So f of 1 over 32. So we're just going to plug in log base 2, 1 over 32 equals y, because I don't know what it is. So we're going to say 2 to the y power equals 1 over 32. All right, they're telling me, same as the last time, they're telling me I need a base of 2. So if you break down 32, all right, that's 2 to the 5th power. We can talk about how to do that tomorrow. I'm just doing that with a factor tree. So this is 1 over 2 to the 5th. And remember, I need a reciprocal of this, and reciprocals happen when we have negative exponents. So this is 2 to the y equals 2 to the negative 5th. Well, if that's my exponent, then that means y equals negative 5. So f of 1 over 32 equals negative 5. All right, I'm not even going to do the last one. I just want you to see kind of how we're thinking about exponents and bases for logs, how those are related.